We're going to start our systems by talking about solving by substitution. Technically, we learned a few different ways to solve systems. We learned how to solve by graphing, substitution, elimination. Guys, so I wouldn't choose to use graphing very often with systems unless it's really obvious and I know the graph paper is right there. Substitution or elimination are kind of more go-to. You will learn other methods in Algebra 2 if you take that class, but at the same time, it's still good for us to review this so that these are strong since we've learned them already. So our systems of equations is basically two variables with two unknowns. Two variables and two equations. So rather than just finding one of the answers, we have to find both the x and the y, or whatever variables they're talking about. So solving by substitution is essentially what it sounds like. We're going to substitute to try to get rid of one variable. Now, substitution problems are typically set up the way you guys see them here, where it tells you something about one of the variables. So it says x equals y plus 9. So what we're going to do is take that y plus 9 and replace it in the other equation, or we're going to place the x in the other equation. So I guess what we want to start off with is we want one variable alone. So in order to do this, we want a variable isolated. So like x equals or y equals. And what I typically do with that is I'm going to use parentheses. I'm going to put parentheses around these. And I'm going to substitute it into the other equation for that variable. So that's our second step. We're going to replace that variable in the other equation. So we're going to place that variable in the other equation. So this is going to go in place of the x. Now, I suggest using parentheses on this step typically. So rather than 5 times x, we're going to do 5 times y plus 9. But then we have to figure out or finish off the rest of the equation. So minus 3y equals 7. Okay. At this point, we're ready to solve that new equation. So we're going to distribute that 5 in. We're going to combine some like terms, so the 5y and 3y can go together. So it'll be 2y. And so then I'm going to move that 45 over. So I'm going to get 2y equals, I'll be a negative 38, I think. This one right. And so we're going to find out that y is negative 19. I believe. Yes. Okay. So the thing is, though, it says 2 variables and 2 equations. We only know one of them. So we do have to take that and put that one back in. The good news is, though, the equation we use to substitute with, that's usually the easiest equation to put the equation back into. So now I know what y is, so I'm going to put that back in to find the other variable. So step 4 is to find the other variable. So I'm going to put that x equals, now I know y is negative 19 plus 9, so I find out that x is negative 10. So we're able to solve both equations there. Okay? And again, this is something we learned in algebra, just we haven't used it much. And I think we did a little bit of substitution in geometry, but definitely not much. Or definitely not systems or much. All right, our next one looks maybe tougher initially, but I actually think it's, once you realize it, it's actually a little bit easier, I think. They both equal y. So what can I do to make the equation, like get rid of one of the variables? Yeah, if they both equal y, then they should equal each other. So we're just going to take the 3x and drop it in place of the y in the other equation. So it'll be 3x equals 7x minus 32.
Isn't that what you would do if you actually, like, because 3x equals y, so you just move it over? Like, there's no other way to do that?
No, yeah, that's it. This is substitution, though.
I'll figure it out later. I don't know.
I guess I don't know what else you do. So we need to solve for our x. So I would move the 7x over by the 3x. I never like leaving one side empty, so I'm going to move this over. And so then we're going to divide. And we're going to find out that x would be 8, negative 32 divided by a negative 4. And then again, I can put that back into either equation, but I usually use the easier one or the one I use to substitute to put it back in. So 3 times 8, so y will be 24. So we found both x and y. So substitution is one of the two methods we learned for systems. Now, both of these problems were set up really well for substitution. They won't always be set up that way. So sometimes you have to do a little bit of moving things around with substitution. For the most part, I'll probably stick more to these types when we're working with substitution or asking you to solve that way. We'll flip the page over when you guys are ready and we'll talk about the other type we learned, which is elimination. And again, both of these we learned in Algebra 1. Okay. So the first equation is set up really well for what we call elimination. Elimination is where we add two equations together, exactly how they are, and we make something cancel. So what we want in this case, so again, we're kind of talking about what these should look like. So what I want for the equations to look like is I want the same number to be in front of the x or the same number to be in front of the y, but the opposite sign. Because I want them to cancel. So when I go to add these equations together, if you guys look, I have a negative x and a positive x. So those two would cancel if I added these equations together. But that means I also need to add the other parts. So 2y and 1y is 3y. And we don't do this very often where we just say, hey, we're just going to add two equations together. Negative 4 and negative 5 is a negative 9. I guess I'm going to write a little bit more as we go through this. Let's see here. Okay. So what I wrote was we may need to multiply first. We'll talk about that in the next problem, guys. And we want to add the equations to eliminate something. Eliminate. And at this, stop the noise. I've asked you guys to stop that before in here. It needs to stop. So we have 3y equals negative 9. So we divide by 3. So y is going to be a negative 3. Once we get to that, then finding the x shouldn't be too bad. I usually pick whatever one that x is like the most simple in. So like the top one I prefer because x is positive. So 2y plus x equals negative 4, but I'll tell you guys, it won't matter which one you guys put it into. So you should get the same answer either way. So I multiply here, 2 times negative 3. We move the 6 back over. So x ends up being 2. So we found both our x and our y. Now our next question, because if I try to add things right now the way they are, nothing would cancel. 3x and x would become 4x, negative 5y and 4y would be a negative 1y. That's not helpful. So we want to figure out what we should do first to make that eliminate. So we're going to be able to do something to the equations to make it eliminate. Any thoughts? Yeah, what do you think?
Multiply the bottom by 3.
Close. I would multiply by what kind of 3 though?
1/3.
I would multiply by a negative 3. So if I multiply this bottom equation by a negative 3, what happens then is we end up with a positive 3 and a negative 3, so those two would cancel. I use that opposite sign because I think it's confusing to change the sign later. So I'm going to rewrite this. The top equation is going to stay as it is. Now, some of these on the homework, you'll have to multiply both equations. So just know that that's a possibility. The bottom row, I multiply everything by negative 3. And the reason we chose a negative 3 is that was the easiest number to cause something to eliminate, to do that opposite. So 3 and negative 3 is going to be 0. Negative 5 and negative 12 is a negative 17. But then this is also negative 17. So we go to divide. And so we find out y is 1. Again, once I know what y is, then I look at the two equations and I decide which one's easier. The bottom equation is a little bit nicer to solve for x because there's not much going on with x. So I'm going to do x plus 4 times 1, that's our y, equals 10. So I kind of choose strategically, but I can choose either. They both should give me the same outcome. So saying, oh, I chose the other equation, I got a different answer, like you probably did something wrong then. So you should get 6. Now, again, guys, with this, realize we could have also solved these by graphing. We could use other methods, but these are the two methods that I'm going to test us on this year now. Again, this is something going into next year I hope you walk in and kind of feel comfortable with. This is kind of just again, like the last 5 days have been basically the first semester of algebra all in like, one, like these few lessons, okay? So I'm gonna get you guys your homework. We do have more time for homework, so I do want you guys to complete this all.